MIG welding is versatility to its core, utilizing dip, spray and pulse transfer. We can weld from thin materials to thick materials, all positional. It's very, very good at what it does. In this video, we'll look at dip, how the process is applied, where it helps, and where it can cause us a few issues. So as with the self-adjusting arc video we did last week, the process in itself runs the same. It's still a MIG-MAG welding set with a constant voltage characteristic power source. The main difference here is the level of amperage that we're putting through the system and the overall heat input in the arc itself. So here we start with an open arc, but now we don't have enough heat, enough amperage to make a burn off rate happen in any real sense. So that arc can now be closed as the electrode makes its way across and makes contact with the workpiece. At this point, we get a short circuit. Because we get a short circuit, we get a high amount of resistance, which makes heat inside the wire. And here we start to get necking. And once we've had necking, the wire will break. A part of it will move across onto the workpiece and produce the weld, and the arc will be re-established. Now this can happen between 90 to 200 times a second. So to give you an example of that, a fly beats its wings at about 200 times a second. So it's repeating. Every time we get that necking and breaking, we produce a decent amount of spatter with that. And that can start to be the problem, really. So in order to try and reduce the amount of spatter we have within our arc, we can use what we call inductance. So this is putting an amount of resistance into the amperage flow. Now what happens here is, when we have an open arc, we have an amperage. That's coming along there on our graph here. Once we have the short circuit, the amperage peaks, and then it'll travel along and we'll have on necking. And when that wire necks enough to break, the amperage falls back, we generate some spatter through the arc of through the force of the electrode snaps, and then we'll return back to our amperage. Now really what's happening here, in that peak of amperage there and the necking we have, there's too much amperage. So when it does snap, the arc has too much force and a lot of spatter is thrown out. So by using inductance, what we do is we put a resistance to that amount of amperage at the peak. So that rounds off the amperage peak and we have less force to create spatter. A lot of sets, the older sets would have 2 or 3 other ports that the return lead can be put in, which normally would have like 1 ohm or 2 ohm symbols above it, or 3 to indicate going higher or lower. And the welder just selects increasing ports until spatter is under control. So in summary, what we have is, if we look at our heat inputs sort of characteristics, well, we're beneath 200 amps, beneath 20 volts low general heat inputs overall. For the shielding gas, we can use 100% CO2 shielding gases now, where in spray transfer we need at least 80% argon to create spray process. Here we don't, because of course we're going to be hitting the electrode off the surface of the job, so cheap CO2 can be used now. What's happening? Well, we've got our open arc, the electrode makes its way through, touches the workpiece, so we get a short circuit, we heat, we get necking, and on breaking we have an amount of spatter. Because overall we have a lower heat input and we're physically touching the electrode to the work we're welding, we can be on thin materials and all position. We're not relying on gravity to pull droplets of weld across the arc. But because of that low heat input, we have the risk of lack of fusion type defects, whether that be lack of sidewall fusion, penetration, or lack of root fusion. There just sometimes isn't enough heat there to make sure that everything melts in all of the time. But we gain the all positional thin materials benefits that make this process change very good for some applications. No, that's it for today. So please remember to leave a comment, like, and subscribe, and stay safe and good luck with your studies.